Welcome to this explainer. Today, we are looking up, way up, to the very top of the derrick. We're going to explore one of the absolute oldest, most brutal, and honestly most expensive killers in the entire drilling industry. We are talking about a catastrophic event that happens in just a fraction of a second. But, as you'll see, understanding exactly how we protect against it reveals some absolutely brilliant, yet surprisingly simple engineering.
Okay, let's dive into this. Picture the scene. You're standing right there on the rig floor, and you look up. The traveling block is rising fast toward the crown block at the very top of the derrick. We are talking about 20,000 pounds of solid steel, moving rapidly upward, being pulled by the Drawworks. That is an enormous amount of kinetic energy, totally controlled by the driller. And, everything is perfectly fine, right up until a single mistake is made.
Because if the driller hoists even just a fraction too far, that 20,000 pounds of steel doesn't just gently stop. No, it violently slams into the top of the derrick. The impact is so intense that the drilling line just completely snaps under the sudden massive tension. And then, that massive weight plummets 140 feet straight down onto the rig floor.
In the industry, we call this nightmare scenario crowning out. It's a catastrophic event where the traveling block slams into the crown block. The result is pretty much always the same. The drilling line parts and the load drops. It's a literal worst-case scenario that threatens the crew's lives and can destroy a multi-million-dollar rig in the blink of an eye. So the big question is, how do we actually stop it?
Well, you might expect the ultimate defense against this to be some highly advanced space-age shock absorber, right? But if you look right between those two massive steel blocks, you're going to find something incredibly primitive: the bumper block. What is it? It is quite literally just a stack of heavy wooden timbers wrapped in some wire mesh, mounted on the derrick structure just below the crown block.
Now, seeing a stack of wood at the top of a modern, high-tech steel derrick feels almost absurd. It immediately begs the question, why not just use a solid steel stop? I mean, if you have millions of dollars of steel machinery up there, why not just weld a massive, totally indestructible steel barrier to physically block the traveling block from going any further?
And this brilliantly illustrates the core physics of the problem. If you hit solid steel, that moving block goes from full speed to zero in a fraction of a single inch. That sudden deceleration creates an enormous force spike, and all that shock is transferred instantly into the weakest link, which is the drilling line, causing it to just snap. But if you hit timber, the wood crushes. It fails predictably. The force curve actually flattens out, and the line survives. It all comes down to the physics of impulse, which is just force times time. The kinetic energy of that moving block is fixed, you can't change that. But the actual force exerted on the drilling line depends entirely on how quickly you bring that block to a dead stop. By extending the stopping distance through just 6 inches of crushable wood, the peak force drops dramatically. The timber isn't there to be strong, it is there entirely to be crushable.
It's really the exact same engineering principle you rely on every single time you drive your car. A modern car isn't safe because it's built like a rigid tank. It's safe because the front end is designed as a crumple zone. It's meant to collapse, stretching the energy of a crash out over a few extra milliseconds so the people inside actually survive. Bumper blocks are, quite literally, the crumple zone for a derrick.
Let's move to and see how this builds into the broader safety system of the rig. Because bumper blocks are definitely not the primary defense. They are a physical last-chance buffer placed exactly where an over-travel is going to happen. Layer 1 is the driller's attention. Layer 2 is the automatic safety systems. And Layer 3, the absolute final barrier, is the bumper block. That wood only gets hit when the driller and the automatic systems have both completely failed.
Take a closer look at that second layer, the Crownomatic. This is an automatic safety device designed to catch a driller's mistake before the blocks ever even touch. When the traveling block passes a predetermined height, the Crownomatic automatically cuts the Drawworks drive and slams on the brake. And a lot of modern rigs even stack electronic anti-collision systems on top of this.
Now, because bumper blocks rely on their own physical destruction to work, there is a super strict maintenance rule. They are completely single-use in a serious impact. Timber that has already absorbed a strike is crushed, it's split, and it's lost basically all of its remaining crush distance. So after any crown out, those timbers must be entirely replaced, and the rig, the line, the blocks, the whole shebang has to be fully inspected before anyone goes back to work.
But here's where we really need to shift gears and talk about the reality on the rig. When a crown out actually happens, it's almost never because the physics failed. It is because of human failure. First up, rot.
These blocks sit outdoors, high up in the air for years. If nobody inspects them, the wood just degrades unnoticed. Second, and this is the big one, bypassing. Pretty much every industry investigation finds the exact same pattern. The Crown-O-Matic was intentionally disabled by the crew with a tie wrap because it quote-unquote tripped too easily and slowed them down during fast tripping.
So the crucial point is this. A rigid steel bumper would actually guarantee a disaster because it completely removes that vital energy absorption. The softness of the wood is the safety feature. Sometimes, the absolute smartest engineering answer is to just use a weaker material. It's literally the cheapest component on the rig, and it's meant to stop the most expensive accident.
Which leaves us with a pretty fascinating thought to end this explainer. We build these multi-million-dollar rigs with incredibly advanced electronic anti-collision systems and automated brakes. But when the human element fails, when a crew decides to bypass a safety switch just to save a couple of minutes, the only thing standing between a normal Tuesday and 20,000 pounds of steel crashing down to the floor is a stack of primitive, crushable wood. It really makes you wonder, doesn't it? How many of our other smart safety systems out there are just one bypass switch away from disaster, waiting for a dumb mechanical failsafe to catch the fall?